Hi, everyone. Thank you for this opportunity to talk with you today about Florida's weather and climate, and particularly how water shapes the weather and climate we experience. The photo I'm showing here is from the Lake Apopka Wildlife Drive in Central Florida. If you haven't done it, I highly recommend it. It's really a great example of Florida's diverse wildlife, beautiful landscapes, and a good reminder of how well suited our climate is for supporting and sustaining our state's diverse ecosystems and economies that rely on them. So with that, let's jump in. Water really is Florida's climate engine, being surrounded by warm ocean waters that drives our daily weather patterns, our seasonal variability. It helps to moderate temperatures on land, but it also drives daily weather patterns and helps to fuel tropical cyclones. Our abundant surface waters and groundwater systems that include our aquifers and many natural springs all rely on that rainfall, especially in summer and fall, for recharging each year. The state's abundant rainfall helps to support not only healthy ecosystems, but important industries like agricultural and tourism industries, recreation, and other public uses that rely on that fresh water. Now, talking about Florida's weather and climate, Florida's climate is really one of extremes. The state experiences a wide range of weather hazards in any given year, from high heat and humidity to extreme cold, abundant, even excessive rainfall, tropical cyclones, and the flip side to that is also drought and wildfires. And of course, we see impacts from rising sea levels with the a number of coastlines we have and severe weather. Florida has always experienced these hazards, but many of them are becoming more intense or pronounced as the climate changes and with land use change. And I'll touch on each of these throughout the presentation. Now, Florida's climate is characterized largely as a humid subtropical to tropical climate, and the southern peninsula's tropical climate varies from a more monsoonal to savanna type climate according to the amount of winter precipitation received there. And given that we are largely a humid subtropical to tropical climate, you might not be surprised to know that Florida is the most humid state in the contiguous US. Yeah, our summer dew point temperatures often exceed 70 degrees Fahrenheit, which can feel pretty oppressive. And these maps show the average annual temperatures on the left and annual average precipitation on the right from 1991 to 2020. This 30-year period is considered our climate normals, which really just give us a sense for what we can expect the climate to be like based on the recent past. Florida is, in fact, the warmest state in the contiguous US and is among the wettest, though annual rainfall here can vary considerably from year to year. And as you can see, the wettest parts of the state tend to be in the extreme northwestern and southeastern parts of the state, while the driest areas on average are the Keys and portions of the interior peninsula, as well as the Cape Canaveral area. And so I'll walk us through Florida's climate season by season, starting with winter. And I'm using these 3-month definitions for seasons, but we'll see that Florida's seasons do not truly follow these 3-month definitions, but they can still be useful as a baseline. So with winter, we're looking at December, January, and February. And this is the time of year when average temperatures across the state can vary the most between the north and south. Temperatures in the north average in the low to mid 50s, as that region is influenced by passing cold fronts from the north and west. And to the south, it's generally much more mild in the mid to upper 60s. January is typically our coldest month of the year, and we often experience temperature whiplash during winter, particularly when we have a more active or amplified jet stream that can bring cold Arctic air into northern Florida and even further south into the peninsula. And then temperatures tend to really begin to warm up in February, as you can see in these three maps, comparing February to the other two winter months. And this map shows when we can expect the first freeze to occur during the season based on climatology with a 10%, 50%, and 90% probability. So looking at the map on the right, in most years, most of the time, the first freeze happens in mid to late December. But about half of the time, that middle map there is showing that the first freeze can occur as early as late November in parts of the Panhandle. And occasionally, the first freeze arrives in early November, which is those dark green counties on the left map. So early freezes, particularly in the fall, can be damaging to fall forages, the harvesting of crops, and preparation of winter crops and fields. And as I mentioned, we can see really cold air outbreaks here in Florida, generally pretty common in the north. I'm going to walk us through three different locations, comparing the number of days when the temperature falls to 28 degrees or lower. These are known as hard freezes. And looking first at Tallahassee, the map there, the graph there at the top shows the number of hard freezes each year going back to about 1940. So you can see that hard freezes are pretty common in Tallahassee. They happen every year on the order of 10 to 20 nights in most years. While moving a little further south to Gainesville, you can see that hard freezes do occur every year, but less common, only about a handful of times, going back to about 1984 or so. And then even further south in Lakeland, Florida, they happen less common, generally only once every few years on average. Again, in Florida, it's really the large swings in temperature during winter that can create problems for farmers and ranchers. We can fluctuate between highs in the 80s to lows in the mid 20s within a week. And if you pair that with drought or previous freeze events, this can lead to a lot of problems with damaged crops. And so it's that up and down that can make things very unpredictable and wreak havoc. Now, snow does happen in Florida. It is rare, but perhaps it's more common than some people may think. We've actually had back-to-back years with snow, but that is pretty rare. Florida typically sees snow or snow flurries somewhere in the state about once every decade or so, sometimes more often. This map shows the maximum one-day snowfall totals recorded in each county over the observational record. And the long-standing maximum snowfall record in Florida was set back in 1954 with 4 inches measured at Milton, Florida. But last year's historic Gulf Coast winter storm in January 2025 far surpassed that record. We had measurements of 10 inches of snow in parts of Escambia and Santa Rosa counties, shown there around Pensacola and Jay and Milton. And so we have far surpassed our long-standing record just last year in 2025. Pretty impressive. And then the map shows other maximum snowfall totals. We had flurries recorded just last month as far south as Lee County in Southwest Florida, and Miami has recorded flurries only once back in 1977. Now, our winter is our dry season, particularly in peninsular Florida. So the seasonal winter average precipitation is just 8.81 inches. The bar graphs on the right show the monthly average precipitation for Tallahassee at the top and Fort Myers at the bottom for comparison. North Florida, as I mentioned, sees sort of a secondary peak in winter precipitation from passing cold fronts that affect the northern areas more often. So precipitation drops off in Tallahassee during winter, but not as much as in Fort Myers, where winters are much drier compared to their summer. In fact, the peninsular Florida region experiences an extended dry season from about late October through April. And one of the biggest drivers of Florida's winter weather is ENSO, or the El Nino Southern Oscillation, which has 2 phases. During the cool phase, which is when sea surface temperatures in the equatorial Pacific Ocean are below normal, this is called a La Niña, and it's shown there on the top left map. This is when Florida is generally warmer and drier than average as the jet stream tends to stay further north. And then during the warm phase of ENSO, called El Nino, conditions tend to be cloudier, cooler, and wetter than average in winter as the jet stream is displaced further south. This is associated with warmer than average sea surface temperatures in the equatorial Pacific Ocean. And the 2 maps on the right show the differences in January precipitation during El Nino years versus La Nina years. So you can see that Florida is generally well above average during El Nino years. Each El Nino and La Nina can look a little different, but this is just averaging all of those years together. And actually, during El Nino, particularly in central and south Florida, precipitation can be roughly double what we might see during a La Nina year. All right, let's move into spring, March through May. Temperatures tend to warm up quickly in spring. Average temperatures for northern Florida are generally in the mid to upper 60s, while areas in the southern half of the state are well above 70 degrees. Much of the peninsula remains dry during spring as that dry season continues until about mid to late May. And the next set of maps are what I showed before, but this time it's for the last freeze climatology. So as I mentioned, temperatures rebound quickly in spring. Typically by February, much of the state is experiencing spring leaf out and blooms. So this makes any late season freezes particularly impactful. And so looking at the same probabilities of 10%, 50%, and 90%, we can see that most years the last freeze occurs by early February in much of the state there on the right. But about half of the time, the last freeze can occur in early March. And on more rare occasions, the last freeze occurs in late March in parts of the Panhandle and early March in north central Florida. Now, drought is actually quite common in Florida and across the southeast US. The region's abundant water resources, our ecosystems, and our agricultural systems have adapted to that frequent and substantial precipitation, which also makes them sensitive to large or prolonged deviations in rainfall. And this graph shows historic droughts in Florida going back to 1970 with different levels of drought, from moderate drought in the light orange to exceptional drought in the dark red. And it shows that about every decade we have had at least one widespread severe drought somewhere in the state. And then more short-lived, less severe droughts happen generally every 1 to 3 years. And spring can be a particularly vulnerable time for drought. As we transition between dry and wet seasons, rainfall becomes more variable. And it's also a time when temperatures are rising, which increases that evaporative demand. And when rainfall drops below normal or the wet season begins later than expected, for example, drought conditions can develop quickly. And as I mentioned, La Niña are years when we have lower than average rainfall, which can increase drought risk as well. And this was actually the case during one of our more recent severe droughts in the state of 2006 to 2007. We had a La Niña developing in the Pacific Ocean, and 2006 actually became our second driest year on record. And by spring of 2007, Lake Okeechobee reached a record low water level, and the lake's water level was so low that it actually created a unique opportunity to do some restoration work on the lake bed, some removal of invasive species and cleaning of debris, and some plantings. So kind of an interesting opportunity there. Florida's wildfire season also tends to peak in late spring to early summer. All right, moving into summer, June through August, our temperatures are now hot. It's pretty humid. This is when the state's natural spring waters that stay around 72 degrees can really help cool people off. And this map shows when the highest temperatures tend to occur during summer. And so for Florida, you can see that peak temperatures tend to occur in mid to late July for the northern half of the state and a little later in August for the southern half of the state. And this is why July and August are nearly tied for the hottest month of the year. Now, the hottest daytime temperatures you might think are going to be in South Florida. And we're defining hottest daytime temperatures here as days where the temperature reaches or is above 95 degrees. But instead, those hot days tend to occur more often inland and in northern areas, as those coastal areas benefit more from diurnal sea breezes. And at night, the opposite pattern is typically true. Coastal areas stay warmer, so nights at or above 75 degrees are more common along coastal regions compared to inland and northern areas. And this is due again to their proximity to warm ocean waters. And we can't talk about heat in Florida without talking about humidity. So the heat index is a common measure of how humid the air is. It combines the air temperature with relative humidity. And in Florida, we often see the heat index peak above 100 during the warm season. This table shows the average number of days over different heat index thresholds for different cities. This is based on the period from 1973 to 2025. And you can see values over 100 are quite common and persistent during the warm season. More extreme heat index values are rare, but do happen occasionally and can trigger these heat advisories or excessive heat warnings by your local weather service office. And you can actually sign up to receive those alerts on your phone. So that's something I would recommend. Averages, however, can be a bit misleading. Of course, some years we see heat index values well above these average numbers or below these average numbers. For instance, Tampa saw 10 days with a heat index over 108. in 2023 during a record warm summer. And they recorded their highest ever heat index of 119 degrees in 2025. So we can certainly see heat indices in the dangerous and even approaching extremely dangerous territory. And while high heat and humidity affect daytime temperatures and particularly daytime heat indices, it can also impact our nighttime or minimum temperatures. And actually, minimum temperatures in Florida have been rising much faster than daytime temperatures. And this table shows the change in the number of warm nights, defined as nights that stay at or above 75 degrees Fahrenheit between the period from 1953 to 1990 and 1991 to 2025. And on average, warm nights are increasing everywhere. These are stations across central Florida. And we can see that they've seen, as much as near a month to over a month more of warm nights over the past several decades. And our summer rainfall averages about 21.8 inches from June through August. But really, our wet season is defined as May through October, and this wet season makes up about 67% of our annual rainfall. And our summer rain is really characterized by extreme hydrometeorological events. We aren't seeing, consistent daily, weekly rainfall. It's typically in the form of daily convection-driven thunderstorms, which can be very localized, which leads to big differences in rainfall over short distances. It's sometimes a bit of a hit and miss in terms of who gets rain and who doesn't. But on average, the western side of the peninsula is generally wetter due to those prevailing easterly winds that help to push convection and rainfall further west over the peninsula. That's what I'm showing here with the map on the right. These are showing wind plots called wind rose plots, and the length of the bars indicate the prevailing direction of the winds. So as those bars pointing toward east are showing stronger easterly winds. Now, extreme rainfall is an important contributor of that variability we see in our wet seasons from year to year. And I've listed a few excessive rain events here in recent years. There are many of these that I could list around the state, but these are just a few examples. For instance, the Plant City area saw a very isolated heavy thunderstorm in July of 2025, with parts of Plant City seeing over 10 inches in about 6 hours. And this can be really problematic for water management operations or agriculture if they receive a month's worth of rain in less than a day. Their July monthly rainfall averages 8.31 inches. So it's important to keep in mind that excessive rain does not necessarily only occur during a tropical cyclone event. We can see rainfall totals in the amount that we would typically see with a hurricane, just with a passing thunderstorm. And with those thunderstorms, Florida does see the highest lightning density in the US, and you might be surprised that Florida leads in lightning fatalities. Most of these fatalities happen during outdoor leisure activities that include things like boating, fishing, swimming, and beach going, which are all very popular activities here in Florida. So these are fatalities that, are largely preventable simply with greater awareness and slight behavior changes, ensuring that people seek shelter and wait out the storm, particularly if you see cloud to ground lightning in the horizon or hear thunder even. Just waiting out that storm can make a big difference. And tornadoes can happen any time of year as well. We do see a peak during summer and specifically in June as that thunderstorm activity begins to ramp up. Tropical systems can also produce tornadoes. We saw a tornado outbreak during Hurricane Milton in 2024. That storm generated 47 tornadoes in a single day, which was a record number of tornadoes in Florida associated with a tropical cyclone. Tornadoes can also occur anywhere in the state. Most tornadoes are on the weaker end of the scale. Only 2 EF4 tornadoes have been confirmed on record, and Florida has never documented an EF5 tornado. Okay, moving into fall, September through November. Fall is really a continuation of these extreme hydrometeorological events, particularly as we move through the peak of hurricane season, which occurs in about mid-September. The two graphs shown on this slide are showing the river flood climatology. At the top, for the Southeast as a whole. So that includes the states of Alabama, Florida, Georgia, and the Carolinas. And at the bottom is the same, but just for Florida. So you can see, looking at that graph on the bottom, that Florida exhibits a unique secondary peak in riverine flooding during about September to October due to continued wet season rainfall and tropical systems that can bring these excessive rain amounts. And stream flows during this time are also linked to the ENSO phase as well. Now, tropical cyclones are responsible for much of our extreme rainfall, particularly during the fall months. Tropical storms and hurricanes can make up as much as 15% of our wet season rainfall in parts of central Florida. That is an estimate from the National Weather Service. Of course, some years it's much more, some years it's much less. Tropical related rainfall tends to also affect much broader areas of the state when they occur. So this map is showing rainfall totals from Hurricane Ian in 2022. You can see that swath of near to just over 20 inches of rain across central Florida. And this is roughly, an amount equal to the total summer average rainfall in just one event. So this excessive rain can cause lakes and rivers to swell. Riverine flooding is a major hazard during these events. This satellite image on the right is showing the Lake Harney and part of the St. Johns River in central Florida. This is before Ian passed over, and this is after Ian. And you can see that parts of the river are much larger than before. And in fact, parts of the St. Johns River stayed in flood stage for 3 to 4 months following Ian. And we do expect rainfall from tropical cyclones to increase with a warmer and wetter atmosphere. In fact, over the past decade, rain has displaced storm surge as the leading cause of direct fatalities from tropical cyclones. And another hazard, indirect hazard associated with these storms is heat. So not a direct hazard, but heat can be particularly problematic after these storms pass, particularly when there are long-term and widespread power outages. This is still a time of year when we're really hot and humid. So that is something to keep in mind as well. And then when we have the quiet season, on the flip side, the wet season rainfall may become inadequate for recharging those critical surface and groundwaters, something we've experienced this year with no landfalling hurricanes. And this can lead to drought in the fall. As our wet season ends, the dry season kicks in. And, for example, this year we began fall already behind normal. This can lead to even flash drought, where drought onset or intensification happens rapidly. These two maps are comparing on the right, departure from normal rainfall from September through November of 2024. If you recall, we had 3 landfalling hurricanes in 2024, which led to well above average rainfall for much of the state. And below that, we had no landfalling hurricanes in 2025, and much of the state ended up well below normal for our fall precipitation. And this led to flash drought in northern Florida, where we had exceptional drought. There in the dark red at the map on the bottom, developed pretty quickly, just in a matter of a couple of weeks between late October and late November. And one final aspect to fall that I want to mention is sea level rise. So sea levels along Florida's coast are rising as they are across the Gulf and Southeast coasts. The arrows on that bottom left map show the direction of change in sea levels, and the colors represent the magnitude of change. So we see different rates of change across this region, but some of that is due to just different periods of record at some of these tide gauges. Sea level rise, is a chronic year-round hazard that can affect flooding at any time of year, but fall is typically when Florida sees its highest tides, known as king tides. So as sea levels rise, that tidal flooding is becoming more common even without storms. And this region has seen as much as a 400 to an 1100% increase in tidal flooding days over recent decades. In Miami, for instance, water levels during high tides now reach levels that used to be only seen during hurricanes. And this is impacting not just low-lying areas of the coast, but it's affecting drinking water supplies and reducing the effectiveness of stormwater drainage systems during periods of heavy rain. So with that, I'm going to wrap up, but before I close, I wanted to mention a citizen science program called COCORAS, the Community Collaborative Rain, Hail, and Snow Network. This is a volunteer-based network of people that measure and report precipitation in their own backyards. It's a national program, and in Florida, we have more than 1,000 active observers. So if you're interested in weather and climate or simply interested in contributing to your larger community in some way, I would encourage you to check it out. The URL is there, cocoras.org. And these data are used by different entities from National Weather Service offices and NOAA to emergency managers and drought monitoring and other groups. So it's a very valuable source of precipitation data. And it's free to join. It does require you to purchase a rain gauge shown there in the center of the screen, which averages about $40. So thanks for your attention. Here's my email and our website address. Feel free to reach out if you have any questions, and thanks again for this opportunity.